Okay, so Unit 2, Lesson 2 is all about the other two buttons on your calculator, sine and cos. We've already done tan. So I'm just going to do a little recall of tan and the formula for tan for the people who are at home. So just to refresh your memory, if we're talking about tan of a given angle, I'll just call it angle A for today, okay? We're going to create a fraction or a ratio. On top of the fraction, we're going to put the side that's opposite to that angle. And then on the bottom, we're going to put the side that's adjacent or beside that angle, but not the hypotenuse, the other one. So tan is opposite over adjacent, okay? So if I'm just going to kind of write it shorthand, tan is O over A, opposite over adjacent. That's how you, O over A. Okay, now there's two more, okay? So today we're going to talk about sine. So for example, if I have sine of angle A this time, sine is also set up like a fraction in a similar way. The side or the fraction on top, the number on top is going to be the number that's opposite angle A. So just like tan is. So we look for the side opposite of angle A. But this time on the bottom, we are going to use the hypotenuse. So on the bottom, we do put the hypotenuse. So for tan, we never use the hypotenuse, but for sine, we do. So in shorthand, whoops, sine is O over H, opposite over hypotenuse. Okay, now the third one we're going to learn is about cos. So if I'm talking about cos of angle A, on top is going to be the adjacent side of angle A divided by the hypotenuse. So if there's three sides in a triangle, opposite, adjacent, hypotenuse, there's three different options of how we can pair them up. Opposite adjacent, that's tan. Opposite hypotenuse, that's sine. Adjacent hypotenuse, that's cos. So cos is A over H. Now, there's a little saying you're going to hear me say a lot, because that's a lot to remember, to keep organized in our head, like which is which. So something I'm going to say a lot is SOHCAHTOA. SOHCAHTOA. SOHCAHTOA is a way you can remember what goes where. Okay, so for example, I put this up in period 1 and they kind of looked at me confused. I'm just going to break it down and explain it to you. Okay, so is sine O over H, S-O-H. Sine is O-H. Ka is for cos, and cos is A-H. Cos is A over H, C-A-H, ka. And tan is O over A. So the front letter is for what one I'm talking about, sine, cos, or tan. And then the two letters that follow are the two letters that make up the fraction. SOHCAHTOA. So essentially for every example today, I'm going to give you a right triangle and you have to tell me based on what we're given, which one of these we have to use. Okay? It sounds really weird right now. It's actually super easy. It's going to fly by. We only have 4 examples. So can I scroll up from this SOHCAHTOA thing? Okay. So, S-O-H, no, so. Okay, so for your first example, we are going to determine the size of the indicated angle. So determine the size of the indicated angle. Here's your first triangle. Ugh, it's hard to draw nice straight lines on here. There we go. There's your right angle. Remember, every question for SOHCAHTOA will have a right angle in it because we need a hypotenuse. You can't have a hypotenuse without a right angle. It's called triangle ABC. We know that this side is 12 meters and that this side is 13 meters. And I'm indicating that I want angle B by putting that line through it. I want to find the size of that angle in degrees. Okay. So if I want to find the if I want to find the size of angle B, that's my eyeball. That's the angle I'm talking about. I'm not worrying about angle A right now, so I'm not going to put my eyeball at A. My eyeball is at B. That's where I'm looking from. So it's like I'm standing at B looking out. According to B, what two sides do I have? Okay, so what's the 13? What side is the 13 in this triangle? The hypotenuse, right? It's the one opposite the right angle. So we for sure have the hypotenuse. Okay. Now that leaves adjacent and opposite. So again, if I'm looking from here and I'm talking about the 12, is that 12 right beside it or is it across from it? It's right beside it, which means adjacent. Sides that I adjacent B and the hypotenuse. Are you with me? Okay, this would be the opposite side to B because it's across the triangle, but I don't know it. So it's not going to help me. The ones I know are the ones that are going to help me, the 12 and the 13. Okay, so the two that I know are adjacent to hypotenuse, A and H. Which one, sine, cos, or tan, deals with A and H? Cos, C-A-H, cos, right? So our setup is going to be cos of angle B is going to be the adjacent side divided by the hypotenuse. That's like the formula we're going to plug into now. So the cos of angle B, so it's going to stay in angle B because that's what I'm looking for. And then on top is the adjacent side. So the 12 goes on top and on the bottom is the hypotenuse. And so now this is just like the tan examples. We're looking for an angle. When you're looking for an angle, you have to press that shift button, or maybe it's a second button, or it might even be an inverse button on some rare calculators. But regardless, you need to access, not the tan, you need to access the cos -1 button. That's the one you need. Whoops. So on my calculator, what I have to do, I have a pretty good calculator. I go shift, then I press cos, so that I get the -1. Then I open the bracket, I go 12 divided by 13, I close the bracket, and I press equals. That's how my calculator works. You may have to divide first. You may have to go 12 divided by 13 equals, and then go shift tan on that answer. Regardless, you should get 22.6. So you'll get cos of angle B, you'll get angle B equals 22.6 degrees, but we want to round to the nearest degree. Whenever we're talking about angles, we typically round to the closest whole degree. So 22.6 would go up to 23. That's the closest nearest degree. Who didn't get 23? Okay, I'll be right there. Just 1 sec. That's another important thing is you need to be in degree. You need to see a DEG or a D at the top of your screen. If you have an RAD, you have a problem. Okay, so you need to go on your screen, go 12 divided by 13 equals. You do the division first, and then second post. Okay? You do the same thing. 12 divided by 13 equals second post. You do the same thing. 12 divided by 13, so you have to do the fraction first, equals. Then you have to press the second post button. There you go. Your calculator is awesome. You're just going to go shift post. It pops it up, open the bracket. Shift post, open bracket. 12 divided by 13, close bracket. Oh, you're ingredients too. See that R? Can't be an R, it has to be a D. So, see this DRG button above? You go shift. You want degree 1. There we go. Okay, so for now I'm using my calculator. I just play around with this, okay? Here, I have one here. Okay. All right, sorry about that. I just had to help people with their calculators. Okay, so we're going to move on to the next example here. Same thing, we're going to find the missing angle. Your triangle looks like this. There's your right angle right there. It's called HKG. You know that this is 6 centimeters. This is 14 centimeters. And we're looking for H. Okay, so friendly reminder that you want your calculator to be always in degrees. So some issues were that they were in radians or gradians. You'll see that little word at the top of your calculator screen. You want to see D or DEG. If you see R or RAD or G or GRAD, that's a problem. Okay, so in this case here, I'm looking for angle H. H is my eyeball. I'm looking from H. Which two sides according to H? Yeah. Hypotenuse and opposite, right? So this is the hypotenuse. The hypotenuse is the easy one to find because it's just opposite the right angle. And then if I'm talking about the 6 and angle H, the 6 is all the way across the triangle, so that must be my opposite. So which one am I going to use? Sine, cos, or tan if it's O and H? Sine, okay? So my setup would be sine of angle H is equal to O over H. Sine of angle H is equal to the opposite side, which is the 6, divided by the hypotenuse, which is the 14. So again, because we are looking for an angle, we have to press shift. Okay, so we just did an example like this. You should be going to calculator now. Shift sine 6 divided by 14. So the only difference here is you're pressing sine instead of cos. Make sure you're pressing the right button. And if you do it properly, you should get 25.3. And we're going to round that to the nearest decimal. So we would round down because 25 is closer than 26. How are we feeling with that? Okay, so it's very similar to tan. The only difference is we just have to figure out, are we going to use sine or cos or tan, depending on what we're given. Okay, we only have 2 more examples, and for these ones, we're going to find missing sides. So determine the length of the missing side. or indicated side. So this triangle is called DEF. I know that this side is 6.8 meters. I know that this angle here is 55 degrees. And I'm looking for that side with the question mark. Okay. So this was similar to the bell work you did today. In the bell work, we had to find a missing side. So when you're looking for a missing side, you'll always be given an angle. Okay, and the angle we're given here is 55. So that 55 is going to be my eyeball. Okay, so according to my eyeball, I am given its opposite side. That 6.8 is opposite my angle, and I'm looking for the hypotenuse. Opposite hypotenuse, OH, SOHCAHTOA, that would be sine. Okay, so we know that our formula for sine is always sine of the angle, so I'm going to write angle E here, and then it's opposite over hypotenuse. That's the formula, and now we plug in the two values that we know. It just so happens here that one of the values we know is angle E, so I'm going to replace angle E with that 55. Then on top is the opposite side, so opposite to 55 is that 6.8. And then underneath the 6.8 is my hypotenuse, but that's what I'm looking for. So I just leave it as an X. It's my unknown. Who remembers from tan what we do when the X is on the bottom of the fraction if we want to isolate X? Emily? Yeah. Yeah. So we take these two terms here and we can just actually switch spots. Okay. So the X pops out totally alone on the left. And then that sine of 55 pops underneath. So they just switched places. Okay, you do not press shift here. You're not looking for an angle. Okay, so just straight up press sine. So you have to go 6.8 divided by open bracket sine of 55. You have to do the 6.8 first. Some calculators, you have to go 55 sine first instead of sine 55. But here's the thing, some calculators are tricky. So listen, most of your calculators will actually do this. If you 6.8 divided by 55 sine, a decimal is going to pop up. That's not the answer. That's just the answer to 55 sine. You have to press equals one more time to get the answer, which should be an 8.3. So if you've got 8.3, phenomenal. If not, you need to let me know and I'll show you how it's done. Some calculators are awesome. They have brackets. So you can literally just type in 6.8 divided by open bracket sine of 55 close bracket equals. Okay, again, if you didn't get 8.3, call me over. You need to know how to use your calculator. Okay, it's not optional. Okay. Last example of the lesson. So for this guy, there's my triangle, there's my right angle, this is B, this is A, this is C, this is 50 degrees right there, this is 5.2 centimeters, and there's my question mark. So I'll let you get that down. Okay, so if 50 is my given angle, that's my eyeball. That's where I'm looking from. So if I'm looking from 50, what two sides am I going to use? Which side do I know and which side do I want to know? Who can tell me? Watch this side right here. The hypotenuse, thank you. And watch this side right here that I'm looking for. Adjacent, it's the one right beside it. So adjacent hypotenuse, A and H, that's ka. So ka toa, that's cos then. So our setup is cos of angle C, that's the angle I know, is adjacent over hypotenuse. But I actually know what angle C is, so it's 50. The adjacent side is my X, and my hypotenuse is on the bottom, 5.2. So this example is different in that the X is on top. Who remembers what we do when the X is on top to isolate the X? We did it literally for bell work. Yes? You got it. We have to cancel out that 5 times 5.2 that's on the bottom by putting a 5.2 on top, because then they cancel. But we have to be fair and also multiply the other side by 5.2. So here on your calculator, I would suggest going cos of 50 first, or 50 cos, get that decimal, and then just multiply that decimal by 5.2. If your calculator is awesome, you can just go 5.2 times, open the bracket, cos of 50, close the bracket, equals. But regardless, if you know how to use your calculator, you should get 3.3 as your answer. If you didn't get 3.3, pull me over and I'll walk you through your calculator. Okay, who got 3.3? Who was able to get that number? Okay, cool. All right. So that's how we use sine and cos. It's just using two different sides. Okay, so ka toa. They're all just using the same three sides, but in different ways. Your practice questions for this are page 95, number 7, 8, and 10, and page 101, number 325. So 3, 4, 5.